Yes.
Okay. Hello, this is Sunghee Park. I'm going to introduce about our research project, video-based pedestrian crossing intention inference using contextual information for urban autonomous driving using PI dataset. This is the contents. In urban environments, regarding to autonomous vehicles, pedestrian behavior is a key challenge in autonomous driving systems. This is because detecting pedestrians' intentions will remarkably enhance pedestrian safety. As you can see in the picture, even though the distance from vehicle to pedestrian is the same, regarding to the road structure and contextual information, the pedestrian's crossing intention is highly variable. The prevalent approach to solve this problem is trajectory-based path prediction. This path prediction focuses on the past observed trajectory of the pedestrians. But motion dynamics keep changing, and this method requires bird's-eye view camera, which is hard to apply on a vehicle. Another approach is intention inference using skeleton features, but this model is only available for short distances. To solve these limitations, contextual-based intention approach focused on contextual information as a remedy for the common drawbacks of pre-approached algorithms. And improving the model network, this approach is applicated in our research. The dataset of our research is PIE dataset. PIE dataset is newly introduced datasets for trajectory prediction with 300K labeled videos and bounding boxes. This dataset provides long sequence video and annotations. Among the annotations, we used the feature of pedestrian ID, bounding box information, and crossing intention probability. To understand pedestrians crossing intention, we introduced a vision-based model using contextual information for pedestrians' intention classification. Our detailed network structure is like this. From the cropped region of interest image as input, data preprocessing and pixel-based image fusion is done to use the contextual information around the target pedestrian. And then after transfer learning to estimate pedestrians' crossing intention, a binary classifier whether or not pedestrian entered the driving lane of the subject vehicle is derived as a final output. In data preprocessing, European network is used and pixel-based image fusion is done to reflect drivable area without spatial information loss. In transfer learning, Resonance 3D, Resonance 2 plus 1D, MC3 has been tried, and high-level features such as movement, position change with surrounding context are learned to infer crossing intention. This is our pre-trained model's performance with different networks. In this experiment, for video representation, R3D, R2 plus 1D, and MC3 networks have been tested. And in order to train the model to learn video representation, additional experiments were conducted by unfreezing previous layers and drivable area segmentation. And it turns out that the input data with drivable area masking helped the model get improved negative and total accuracy. But there are 4 times more positive label data than negative label data. This unbalanced data makes relatively low negative accuracy. And if the model predicts only positive answers due to the data unbalance problem, as I mentioned, the accuracy can be over 0.80. So it turns out that testing in an unbalanced situation is not meaningful. Because it was important to get higher negative accuracy for reliable crossing intention prediction, we tested our model in balanced data. And our best model compared to our baseline improved the overall performance significantly with reliable accuracy, which is 0.73. And comparing our model performance to the previous PI data related literature, our model outperformed without additional information. And also our model is conceptually and computationally simpler than the previously reported PIE model. This is the visualized results of our pedestrian intention estimation. I will show the video of our output. Colored box shows crossing intention prediction. This is the sequence video example of our model output. You can see the colored box showing the crossing intention in the video. As the further works, testing on additional data set and crossing intention estimation considering previous intentions are required. Even though we tried to reflect previous intention in our experiment with fusing previous output and adding stacked loss term, it ended up with poor performance. So more appropriate way to reflect previously estimated intention is required for further works. Thank you for listening.
Thank you. Any question? I have a question about the experimental results table. The previous one, yeah. Here you say that the first row is our model, and the last two rows are also our model. So which one is yours?
I mean, the first one is with balancing data, and no, sorry. The first one is with unbalanced data, and the last one is with balanced data. Because the output is very different in balanced data and unbalanced data, so we should have to compare these two options.
So PIE is the baseline, and your model...
No. Baseline is also our model with baseline score, and even it was baseline score, it was better or very similar with the PIE data performance.
What is PIE? Is it a data set or a previous model?
Yeah, it's also data set, and also it's the literature review with PIE data set. The PI method is also the best performance as reported in the literature review with PI dataset.
Okay. Usually the baseline means the competitors, and you use ours for your own model. So when I say it's a baseline, that yeah, I think the PI is the baseline here, and what you say baseline is actually your model. So okay, sounds good. Okay, any other question? Okay, thanks.